Alright, so number 12 is saying find the indefinite integral and check the result by differentiation. This right here, you won't have to do that going forward. It's just as you are learning, it's to make sure that you can walk forward by deriving and walk backwards by anti-deriving, okay, or integrating. Alright, so another way that I could write what you see, and this is probably most likely the way it's going to be given to you initially, looks like that. Can someone tell me what my variable is? Theta. Okay? Theta is like x. We don't know it yet. Okay? Can someone tell me what d theta means in context? Not in terms of theta, in respect to theta. Okay? So when I've been deriving the first semester, we had x squared, and we were deriving this to get 2x. This means that it was taken in respect to x. Remember implicit differentiation when y was y, when y was y prime? Okay? This right here says the function has to be written in terms of x in order to be differentiated in respect to x. So over here, this function has to be written in terms of what? Theta. It has to be written in terms of theta in order to be integrated in respect to theta. Okay. Notice the rewrite. The secant squared, the way they wrote it, this is the only way that you can put this into the calculator for it to register. That's how you're going to see secant squared. You cannot put this into the calculator like that and it to interpret secant squared. Okay? Just want to make sure if you don't already know that. Looking at this, to make it easier, I would constant multiple rule out the 8, and I would also break it up into two different integrals. Okay, so you have d theta for one, you have d theta for the second one, constant multiple rule this -5, and I'm left with the following. So guys, I'm going to take this integral in respect to theta. That means everything written here must have what variable? Theta. Okay? It has to have a variable. On one of the tests, remember that one question that I put on the test that e's were everywhere, and I told you to take the derivative? And y'all put all this chain rule, product rule, quotient rule, all this stuff, and what was the derivative of the whole thing? 0, because it never had an x. Remember that one problem? Okay? This says the same thing. You're anti-deriving everything that has a variable of theta. Nothing else. Okay. Guys, what's the backward process antiderivative of secant squared? Tangent. And you know that from that table that we wrote on the other problem, okay? Coming back as tangent. What allows me to bring this 8 down? Constant multiple rule. There's multiplication. What's the antiderivative of sine? Be careful. Negative cosine. And if I bring down, notice the parentheses. This is very important. Okay, otherwise I think I'm subtracting cosine, which I'm not. There's a difference between subtracting cosine and multiplying by a negative. Okay? Can I bring -5 down, yes or no?
Yes.
Yes. Why? Constant multiple rule. And right here is a huge mistake that people will start making, because instead of subtracting 5, they should really be doing what? Adding 5. So it'll be +5 cosine of theta, and then plus c at the very end. Now notice in WebAssign, they put sine over cosine instead of tangent. Each one is equivalent. Each one is okay because they're equivalent. Any questions? Again, cosine can be jacked up sometimes. The try another version that sometimes you've grown accustomed to, be careful, okay? Be careful of making sure it's reflective of techniques that we're doing here in class. Because if it's not, you need to ask, hey, does this work all the time, or should I use this? Okay? Question?
I answered.
Okay, cool. So it'll be plus c there at the very end. Just don't forget the c.